In problem number 20, we're told that the position of a particle on the x-axis at time t is negative 5t squared. Then the average velocity of the particle for t greater than or equal to 0, less than or equal to 3 is. When we're looking for average velocity, that's the same as the slope of the secant line connecting the endpoints. And so that will be, if the position particle we call position function, we call s of t or x of t, either one is okay, is equal to negative 5t squared, then the average velocity would just be, from 0 to 3, would be s of 3 minus s of 0 over 3 minus 0. And s of 3 squared is 9. We're going to get negative 45. S of 0 is just 0 divided by 3. And so negative 45 over 3 is negative 15 units. We don't have any units here, so it's just negative 15 in that case. And that's all we have to say. Alright, so next problem. A particle moves along. Remember, so let me just go back to number 20 here. Average velocity is the total distance traveled over the total time elapsed. That's all it is. Distance over time. The rate is equal to distance over time. Next, a particle moves along the x-axis at any time t greater than or equal to 0. Its position is given by x of t is t cubed minus 3t squared minus 9t plus 1. For what values of t is the particle at rest? Particles at rest is at rest when v of t is 0. When there's no velocity, then the particle is at rest. And we know that velocity is the derivative of position. So if x of t is equal to t cubed minus 3t squared minus 9t plus 1, then velocity is the derivative of position, and in this case it would be 3t squared minus 6t minus 9. We can factor out a 3 from that, and we'll get t squared minus 2t plus 3, and we want that to equal 0. And that'll equal 0 whenever 3 times. We'll look to factor that. T, and 3, and 1. We want that to be negative and that to be positive. So when t is equal to negative 1 or t is equal to 3. But because we're told that t has got to be greater than or equal to 0, so that one doesn't work, and our only solution is t equal 3. We'll go on from that. Next, number 22. The position of a particle moving along a straight line at any time t is given by s of t, t squared plus 4t plus 4. What is the acceleration? Well, acceleration is the derivative of velocity. It's the rate of change of velocity. So it's the second derivative of position. So let's see how this goes. S of t is equal to t squared plus 4t plus 4. Then v of t is just s prime, the derivative of position, and that is 2t plus 4. That 4 didn't come out right. Now, acceleration is the derivative of velocity. It's also the second derivative of position, and so that is just 2. So it doesn't matter what the time is, the acceleration is constant, and so it will be equal to 2. We'll go on and see if we'll continue one more of these here before we break for the next video. A particle moves along the x-axis so that its position is given by x of t is t squared minus 6t plus 5. For what value of t is the velocity of the particle 0? So we have x of t is t squared minus 6t plus 5. Velocity is the derivative of the position function, so it's just 2t minus 6, and that's equal to 0 when 2t equals 6 or t is equal to 3. And we'll go on to the rest of these videos in the rest of these problems in the next video.